A common table expression is a feature that was introduced with SQL Server 2005 that allows you to code an expression that defines a derived table. You can use common table expressions to simplify complex queries that use subqueries, and this can make your code easier to read and maintain. To begin coding a common table expression, the statement for the query must begin using the with keyword to indicate that you are about to define a common table expression. Then it specifies the summary as the name of the first table, followed by the as keyword, then by opening parentheses to include the select statement that defines the table. You can also code multiple common table expressions using the comma to separate them. Common table expressions can be used with the select, insert, update, and delete statements. However, we haven't covered the insert, update, and delete statements yet. We will do that in a later video, but today's example is going to be on how to use them with the select statement. And this is because you will most likely find yourself using them with the select statement more than any other statement. So I'm going to write a query here that uses two CTEs and then joins them together into a final summary result set. So the first CTE I'm going to make is the summary CTE. So I'm going to use the with clause, and then I'm going to say with summary as, and then in parentheses here I'm going to put a select statement here, and I'm going to select all from my invoices table, and then from my invoices table I'm going to join in the vendors table, and I'm going to do that on the invoices dot vendor ID is going to be equal to the vendors dot vendor ID, and then in here I'm going to group by vendor state and vendor name, and then some columns that I want from here. I'm going to get my vendor state, and then I want my vendor name, and then I want the sum of my invoice total. I'm going to name that sum of invoices, and that's going to be my first CTE. And my first CTE is with summary as, and then I'm selecting the vendor state, vendor name, and then I'm getting the sum of my invoice total, and I'm naming that sum of invoices. And then what I did was I joined over to the vendors table on the vendor ID, and then I grouped these by vendor state and by vendor name. And so if I want to use the CTE in another query, I have to know that I'm only going to have access to the vendor state column, the vendor name column, and the sum of invoices column. The three columns here that I have listed out in my CTE, that's what I'm going to have access to in my next query or in any other join that I use that wants to utilize this derived table. So the next CTE I'm going to create is called top in state. So I'm going to say top in state as, and then I'm going to open up two parentheses again, and then I want to select my vendor state and my max sum of invoices. This is coming from the first derived table that we created, the summary derived table, and I'm going to name that sum of invoices again. And that's going to come from summary, which is the derived table we just created, and then I'm going to group by vendor state. And so what we're doing is we're getting this vendor state from the summary table, which is our derived table here, vendor state, and then we're getting the maximum sum of invoices, which is the maximum sum of the invoice total as sum of invoices from the summary table, and then we're going to group those by vendor state. And then what I want to do is now I want to use both of these derived tables in a final query that joins them together into a final summary result set. So I'm going to select my summary dot vendor state, then I want my summary dot vendor name, and then for my second derived table, top in state, I'm going to get my top in state dot the sum of invoices, and then this is going to come from the summary table, and then we're going to be joining this on the top in state table. These are both derived tables, and then that's going to be on the summary dot vendor state. I'm going to set that equal to top in state dot vendor state, and we're also going to join it on the summary dot sum of invoices equal to top in state dot sum of invoices. And then we're gonna, to finalize this query, we're gonna order this by summary dot vendor state. So you can see here, when using the join and you're joining on a key, you can do more than one by using the AND clause here to specify that you want to join your tables on more than one column. And so now we're going to run this entire query all together, and you see we have our vendor states and our vendor names grouped together, and our sum of invoices, which is the maximum sum of the invoice total. And we displayed all this data in two separate tables, and then we accessed it using derived common table expressions, joined them together to seem as if they were two tables, but they were just derived tables. And we got a single result set here. Now notice I didn't use another with clause when I coded the second derived table. And this is because each CTE can refer to itself and any previously defined CTE in the same with clause. You just have to separate them with the comma. So that's what we did here. We didn't have to use another with clause here for top in state CTE. We were able to use the same with clause from our summary one just by using the comma separator here. And that's how we were able to create two derived tables using the same with clause, two separate common table expressions. Now there's another form of a common table expression that can be used, and it is called the recursive common table expression, or recursive CTE. A recursive query is a query that is able to loop through a result set and perform processing to return a final result set. For those of you that are not familiar with what loops are in programming, a loop is a sequence of instruction that gets continuously repeated until a certain condition is reached. You may be fetching data and trying to change it, then you'll have a condition that checks whether or not the data matches, and if it does, you would change the data in multiple rows. So now let's take a look at some examples. So just like I did with my last CTE, I'm going to say with, and then I'm going to name my CTE, and it's going to be with employees CTE as. I'm going to open up two parentheses, and inside here is going to be where my select statement is going to be. And then what I want is I'm going to select all from the employees table, and the employees table is going to be on my examples database. So I'm going to get examples.dbo.employees, and then I want to say where my manager ID is null. And then I'm going to pull some columns out here. The first column I want is my employee ID. And then I want to use a concatenation. I believe we went over concatenations already. I'm going to say I want my first name plus, and then I want a space between it, and then I want to say plus my last name, and then I want to name that as my employee name. And then here comes the recursiveness of the CTE. I'm going to say one as rank, and what this is going to do is this is going to display the number one in a separate column named ranked right beside the employee ID and the first name, where the manager ID is null from the employees table. And then I'm going to use a union all, and then what I want from this union is I'm going to select all from my employees table again. That's going to be on my examples.dbo.employees table, and then I want to join in my employees CTE, which is the CTE we just created, and I want to do that on my examples.dbo.manager ID. I'm sorry, that my examples.dbo.employees.manager ID, because we have to go database.dbo.table.column ID. And then that's going to be on my derived table, my employees CTE dot employee ID. And then we're going to come up here and we're going to pull some columns out. The first one I want is I want my employee ID from the employees table. So it'll be employees dot employee ID, because if I just specify employee ID, it could be coming from the employees table or the CTE, employee CTE. So I have to specify which table I want it to come from. And then I'm going to use the comment separator, and then I'm going to perform another concatenation. And it's going to be my first name plus a space in between, and then plus my last name. And then we're going to grab the rank column from our CTE table that we created up here, and we're going to say rank plus 1. So what we're doing is we're saying 1, plus 1. And what it's going to do is it's going to do a plus 1 on the rank where the manager ID is null for these employees. And then we're going to end that, and I want to select all from my employees, my CTE table, and then I want to order by the rank. That's the column we created, and then my employee ID. And then I'm going to run this query. And oops, the only thing I want to run is this here. Yep. And so now we see we have our employee ID, and where the manager ID is null, we have incremented that rank plus 1. And so the manager ID obviously was not 1 for Cindy Smith. I'm sorry, the manager ID obviously was not null for Cindy Smith under the employee ID of 1, so she received a rank of 1. But as soon as it got to Elmer Jones, his manager ID was null, so we incremented the rank by 1. Now it's at 2. And then when we got to Paulo Locario, I suck at pronouncing last names, guys. But when we got to Paulo here, his manager ID was not null, and so the rank stayed at 2 and did not increment. But then when we got to Ralph here, his manager ID turned out to be null, and we had to increment it again by 1, and then it got to 3. But when we got back to Olivia, her manager ID was not null, so it stayed at 3. Same for Thomas, and same for Rhea. It still stayed at 3. As soon as we hit Robert, his turned out to be null, so we turned it into 4 and incremented it. And then right when we finished off with Denise here, it did not increment again, and her manager ID was not null. So this is how you use common table expressions to write a recursive query, which is known as a recursive CTE, which is what we did here. Now keep in mind now, a recursive CTE must contain at least 2 query definitions, which is what we have here, and we use the union all clause because we combined 2 select statements, which gave us the minimum requirement of 2 query definitions. Our anchor member and a recursive member, and these members must be connected together. What was our anchor member? Our anchor member was this first query here where we initiated the rank column as our anchor, and then we recursively looped that anchor, which was rank plus 1. So this was our recursive member here, and then this was our anchor member, and then we use the union all operator to combine the 2 query definitions together. So that is all for this video. In our next video, we are going to begin talking about how to insert, update, and delete data from tables. If you are interested in the next video, head on over to database-tutorials.com. If you liked this video, hit the like button. If you disliked it, well, you know what you got to do. Don't forget to subscribe to my YouTube channel, and see you next time.